So today we're going to be looking at area. So we're looking at area of different shapes, particularly rectangles, triangles and circles and things like that. Most of this should be just a reminder from previous years. So hopefully you'll remember that a rectangle, to find the area of a rectangle, so to find an area of a rectangle, it is the length times by the width. But what does that even mean? Why am I even multiplying this sort of thing? Why am I multiplying the length by the width? So what we're going to work at, just to talk about beforehand, before we do this, is where do these formulas come from? So the area is the space within a shape. So it's this entire section. Okay? Now you'll notice, or you might remember, that they have certain units as well. So let's say, for instance, this rectangle was 5 centimeters long and 3 centimeters wide. Now the area, what we do, you'll remember that area is length times width. So this would be 5 times 3, which is 15 centimeters squared. You might remember this sort of formula, that kind of thing. But really what we actually should be saying is not centimeters squared, we should actually say 15 square centimeters. That's, technically speaking, what it should be called. Because basically what we're saying is that within this rectangle, there in fact can fit 15 square centimeters. So what do I mean? If I was to break this particular rectangle up, and I had a square that each square had a distance of 1 centimeter, 1 centimeter. So each one was exactly the same. Please just pretend that my drawing, they're all exactly the same. But essentially 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. That's 5 that way. And then we've gone down, so all the widths are 1 centimeter. Basically I can fit 15 of them inside. So that's why we do length times width. It's the same result. What we're saying is, how many of these centimeter-sized squares can I fit inside here? So when it comes to a larger shape, for instance if they were in meters, we're asking how many square meters, so how many squares that are 1 meter by 1 meter can they fit in? Or how many square kilometers that are 1 kilometer in size? Okay, so that is where the y length times width, where that actually comes from. So it's not just a formula that came out of nowhere. It actually came from this. I've got here a triangle. Now you might remember that a triangle, if this is the height, the up bit, and this here is the base, that an area of a triangle, which we can label, just instead of writing area of a triangle, one of the ways we can do in maths is put a big A, a little triangle. And what we say is that it's half of the base times height. But why? Why do we say that? Well, you'll notice that this base times height is very similar to length times width. And that's deliberate. The reason it's very deliberate is if I was to put another triangle, the exact same size, so it had the exact same base and exact same height, but just flipped it upside down and chucked it on there, I've got myself a rectangle. In this case it kind of looks a bit squarish, but still a rectangle. A square is a type of rectangle. And so basically what we're saying is that a triangle is the same area as a rectangle, just halved. So therefore, if I want to find a triangle, it's the same as finding a rectangle and then halving. Sometimes you see diamond-looking shapes like this. So they're either a kite or a rhombus. A rhombus, all sides are the same. And to tell the difference between a kite and a rhombus in a diagram, or to demonstrate that you've drawn one, is we put that line indicator in each one, knowing that they are the same size. If it was a kite, then 2 of those sides would be different, and we would label it like that. So those 2 sides are the same, and those 2 sides are the same. Thankfully, the formula for the area is exactly the same in both. in both the kite and the rhombus, the width and the height, when you multiply them together and then halve it, then what you've got there is the area. Now this is again very similar to the triangle, and basically it works in a very similar sort of way. Another way you could actually work this out, if you forget the formula, is to break the shape up. In fact, I highly recommend whenever you find a shape that you don't recognize, break it up into shapes you do. A trapezium, or trapezoid as they call it in America, looks something like this. And basically it's a rectangle and two triangles put together. Now, of course, you could actually use this and this knowledge to go and work it out that way. You could work at the area of the rectangle part and the area of the two triangles. Thankfully, a mathematician much earlier than us has come up with a handy formula. The formula for a trapezium is 1/2 of the area, or we add the top and the bottom together. So A is for the top, B is for the bottom. So remember B for bottom. Add them together, halve that, and then times it by the height. So where do these formulas come from again? Well, what they have done is they've simplified very complicated ones. And a little bit later I'm happy to show where these proofs come from. But for now, just to remember the formulas. And these are worthwhile putting on your summary sheet for your test. This is the circle. Now the circle area is one thing that confuses a lot of people, because it's a formula and they don't quite understand what it means. It's like a pi here and something squared and whatever else. And this is why it's worthwhile remembering that a radius is half of the diameter. So what does it mean? So hopefully you might vaguely remember that the area is equal to pi r squared. So what does that actually mean? Well, imagine if the radius squared is just like in with a square, and it's actually literally a square. So radius squared looks like that. Okay. So each radius squared looks like that. Now remember that pi is equal to 3 and a bit times radius squared. So what does that literally mean? It literally means that the area of a circle is 3 of these squares and a little bit left over. So we realize we can fit another radius squared, a third one. Now you'll notice all these outside bits, all these bits that are on the outside. Well, basically they fill up. If I was to take this one out, it would become probably in here. Take this one out, that would fill up in there. This one in here, fill up in here. So you'll notice here that the extra bits, the bits we cut off, if we took them off and then smushed them all together, they fill up most of that fourth bit of that circle. But you'll notice I have a little bit left over. Well, that's the 0.14 whatever. So that's what this means. It means that the area of a circle, I can fit 3 and a bit lots of that radius squared. That's what it means. Now, if that's confused you again, then I would suggest not to worry. Just remember the two things. With anything measurements with circles, they involve the r, and also with pi. So everything involves pi. And remember, you should use the pi button in your calculator. A parallelogram is basically a rectangle that's shrunk too much. It's just fallen over a little bit. So basically we work it in exactly the same way. So you'll notice it'll have a height, it'll have a base. Parallelogram, why? Because the lines are parallel to each other. They don't cross over. So this line and that line's parallel, that line and that line's parallel. And the area is just the base times by the height.